This is Geometry, Chapter 4, Section 5, in which we will continue proving triangles are congruent, this time using ASA and AAS. Okay. Last time we talked about SSS and SAS. And particularly when we got to SAS, we had to talk about the included angle. The angle between the two sides. Well, there's a similar idea called an included side. That is the side located between two angles. And knowing that helps us set up our third postulate of the chapter, postulate 4.3, the angle-side-angle congruence, ASA. If we have two angles and the included side of one triangle congruent to two angles and the included side of a second triangle, that's enough to say we have congruent triangles. We don't have to get to all six, remember. All we have to get to is three things. An angle, a side, and then an angle. They have to be in that order consecutively. So we're going to continue practicing some of our different styles of proof. We're going to do another flow proof to get more of a feel for that. Given that we know this line ZX bisects both of these angles. It bisects angle WZY and it bisects angle YXW. Then our job is to prove these two triangles are congruent. And we're going to do this with a flow proof. So we'll start with the given information. And I split that given information into two separate lines so that I could talk about it a little better. ZX bisects angle WZY down here. And ZX also bisects angle WXY. I switched the order around on the letters on that one, but that really doesn't matter. And that's our given information. Okay. Well, what does it mean to be a bisector? It means that we get two congruent angles here. We get these two angles are congruent, WZX and YZX, and also we get those two angles, WXZ and YXZ. Just because we know this is a bisector, that means we get two sets of equal angles. Okay. Now we know something else. We know ZX is equal to itself because of the reflexive property. Now again, when we're trying to prove congruence of triangles, that's a case where we're going to need to use our reflexive so that we can establish we have everything we need. So now what have we got? We've got an angle matching an angle, a second angle matching a second angle, and the side in between them. We have everything we need. Two sets of angles here, a side here, we put it together, and we can say these triangles are congruent by ASA, angle, side, angle. Okay. Now our next one is actually a theorem and not a postulate. It's the angle-angle-side theorem, AAS. In this case, we can have the two angles and a side that's not in between the two. Okay, jumping back here, we had the two angles, we had the side in the middle. We could have used this side YX and this side WZ if we knew those were congruent. This theorem would allow us to use that. So if two angles and a non-included side match up with two angles and a non-included side, then that's good enough. Okay. So let's explore this idea a little bit. We're given here that RQ is congruent to ST, and RQ is also parallel to ST. Now I'm going to notate that information on the picture. I'm going to mark these as parallel by putting these little arrows on them. And I'm also going to mark them as congruent to each other. Okay. So I'm going to start with the idea that they're parallel to each other. Now, last chapter we did a lot of work with parallel lines. And we, among other things, learned if we have parallel lines, then alternate interior angles are congruent. So angle R up here would have to be congruent to angle T. Oh, sure, I did the other one. So this angle down here at Q would have to equal this angle up here at S, because of the alternate interior angles theorem. You could look up the number if you wanted to. It's not worth it to me. I know the name. Now we're also going to say RUQ is equal to SUT. Erase that. Okay. What kind of angles are those two angles we just marked? They're vertical angles, so we'll use the vertical angle theorem. Now, what have I got? I've got two sets of angles. Oops. I erased the wrong one. Huh. There. We've got two sets of angles, and we've got the side not in between them, because that was given to us. We've had a little trouble along the way this year of when they split their givens apart, so I wanted to show you that again, that it's legal to do. So now we have enough to say we've got our triangles by angle, angle, side. We could have, instead of using these vertical angles, we could have used these other alternate interiors, the ones that I marked the first time, and then used angle, side, angle. That would have worked as well. Now there are a few congruence theorems that only apply when you have right triangles. And we're going to kind of go through these quick because they're related to the other ideas. If we're looking at right triangles and we have the legs matching up, both sets of legs of the right triangle are congruent, that's good enough. That's basically side angle side, because the angle in between the two legs is the 90-degree angle. So if you don't remember leg, that's okay. Theorem 4.7 is the funniest theorem in all of geometry. It's so funny that the name is hypotenuse angle congruence. If you have the hypotenuse and one of the acute angles matching the hypotenuse in one of the acute angles, that's good enough to say they're congruent triangles. This is basically angle side. We have one angle already, and then we have the right angles. So you're basically looking at angle side, just in a right triangle. Two more here. If we have leg angle, LA, if you have a leg and then you have an angle, one of the acute angles, then you're basically an angle side angle. And we can draw a picture of that in class if you want to see that. And then finally, if you have hypotenuse leg, HL, if you have the hypotenuse of a triangle matching the hypotenuse and one leg matching a leg, you're basically looking at side, side, side. So if you don't remember these four theorems, if you don't think of them when you're doing things, it's okay because you can still use the ones you already know to fall back on. Okay. As always, if you had questions along the way, hopefully you wrote those down. Bring those in with you, and we will see you in class.